Thank you very much for, I'm glad to speak in front of you guys. So I am going to switch to a topic that is, we've heard quite a bit about all sorts of technologies that are coming up. They're all very exciting stuff. And I'm going to, for a change, talk about something really boring, though there is actually a connection. Really boring, but I think very relevant for a lot of people. But there is a connection, I think, with a lot of the other topics that were discussed, because they all involve something that we're waiting for. We're waiting for, those new technologies come down, and this is something close, which is working with what we're calling broken APIs delivered late, right? And I guess we're not showing all of the red ones, but some of the colors. But for some reason, I don't see the color. Oh, well, the colors are a little tweaked, so the titles, I'll have to read them out. So a fairly common case that I'm sure all front-end developers have experienced, which is that you're building your front-end application, but your front-end application ultimately will need to talk to some back-end API, right? And so where you are in the role where you're going to be doing the front-end, someone else is providing the back-end. Now, if you're doing full stack, sometimes it's awesome because you can actually do both, but oftentimes this responsibility is split. So I'll just read out the bullet points for you. I'm not sure why the colors-wise they're not showing. So how does this usually work? Well, a common case is why is it one behind? Oh, yeah. So the API team provides you with the API, and they normally would do it when promised, which is to say before you start working on your part, right? That makes sense. And the API that they provide would usually be complete when they provide it to you, and it will usually work flawlessly. And most important, it will never change once it's delivered, right? So this is, I'm sure, matches everyone else's experience with how backend APIs work, right? Unfortunately, for some reason, just doesn't seem to work for us. I mean, now we are a consulting company. We build applications for clients. We've done dozens of projects. There's maybe one or two projects where we could say sort of, if we squint a little bit, this is sort of how it worked, but not really quite. So the reality usually is very different, right? So the reality is, first of all, before we even get into delivery, who even knows what a good API, what a good API is? Now, hopefully you, because I think oftentimes as a front-end developer, you would think, well, the back-end guys ought to know this, but there is a good chance you're working with a back-end team that is actually themselves transitioning from PHP services that generate HTML directly, and they think that if something goes wrong inside of their database, then the right thing to do is to send you an HTML message with a PHP stack trace, right? So you actually, obviously, as a front-end developer, actually need to take a lot of initiative to really push the definition of what is a good back-end API. So hopefully you know this. So now the second one is who's going to test it? Again, the answer is probably you, right? Again, maybe you work in environments where always those things deliver to you fully tested, but usually knowing the testing tools is really important. Now, when it will be ready? Now, this is the biggest question of all. So in fact, because of that, based on our experience with many projects, we provide a little translation sheet. So this is how you know when to expect. So you listen to what is being said to you, and if you're being told that it's working now, then it means that it's probably working, but it hasn't been tested, and it will probably be redesigned completely as the project unfolds. Now, the second possibility is someone tells you, well, we'll have it in a few days. Now, this probably means that you will see the working API in maybe a few weeks, maybe a few months, depending on how lucky you are. And then finally, if you hear we are working on it, then you really need to brace yourself that potentially you're going to have to complete your work, not just get started, but complete your work before you actually see the working backend API at all. So what do? So you have to prepare for the worst, right? The broken API that is delivered to you late in the project, right? And so we at Angular have basically found that, well, we can't really just go ahead and wait in situations like that. We do short engagements. We try to usually build a complete app in a couple of months for a client. The fact that API is, I mean, if we're going to be sort of pushing back projects where the API isn't delivered on time, we really wouldn't have much work to do. So we've been looking for all sorts of different solutions. And so we kind of settled on what we are calling the HackStack. And it's really an approach to working with broken APIs that are delivered late. And when we Nick and I did a version of this talk at ngconf at the Hack Night, which was very appropriate title-wise. And we said at the time that HackStack is not really a library, it's not a tool, it's really just sort of a set of best practices we've developed. And people come up to us afterwards and said, well, that sounds like, we agree with everything you guys are saying, this sounds like good ideas, but where is the code? We want, why is it not a library? Why is it not a tool? So we've gone back and we said, well, I guess there's demand for it. So we went ahead and so now it actually is a library. So we've took some of our own, no, we would do early on, we're doing this in a very customized way inside different projects. So we've put some of those things together, we made it a library, and we are now using that on our own project, and we invite you guys to use the same. You can also, however, if you don't find that this particular implementation suits your needs, then you could use this as for inspiration. So mocking with HackStack, how does this work? Well, so let's talk first about mocking the API in general. Now, first of all, before you start mocking the API, you really ought to put your best effort into documenting it, because obviously, the closer agreement you get with the backend team up front, the less rework you'll have to do later. And there's a few tools that really help in that regard. We recommend actually sticking with things that are lightweight, but at the same time, you also have to watch for how much understanding the backend team has of what a good API is, because that really varies sometimes. Now, the second is that nothing that I'm saying here is a replacement for test-driven development. I mean, your test-driven development really should be your first go-to solution. You're writing a service. That service you should have tests that actually test the service with no external calls whatsoever, right? But you do run into limitations of that, and sometimes you wish you actually had the API that was promised to you. So there's online tools that allow you to do that. We found all of them too limiting in terms of what we wanted to do. We've looked into a solution of using a mock server. So basically, we don't have the real API, but we are a full stack development shop, so we can go ahead and actually build one in Node.js. This approach can work quite well. We found that it can be fairly expensive. And so what we've settled on for most of our projects is client-side mocking, which is basically we write code inside the client that mocks the functionality, the data that we will expect from the server. And so HackStack.js, I'll talk more specifically. This is a library that we're offering that that implements some of the most common functionality. It implements both some of the higher level functions and some of the lower level functions that you can actually try to build your own solution on top of it. So first quick point, if you want to get HackStack, you can get it just with Bower now. You can do Bower install Angular HackStack. In case you're wondering, there's supposed to be titles on them for some reason that are not showing up, none of them. So, but it's also available on GitHub, so wrangle/HackStack. And no, we're calling this version 0.1.0. It can be used. It works. We are still trying to see how well it's going to end up being suitable. So there may be some API changes, and we actually really want to hear everyone's feedback. So there's probably going to be slight changes. And I wanted to thank Brian Olinik and Ahmed Al-Sudani, who are two Wrangle developers who actually did all of the code, including most of the examples that I'll be showing. I just stand up and do the presentation. Oh, and finally, the slides. Oops, that was slightly out of order. If you want to get those slides with all of the examples, it's http.yto.io/xngu. You can get them there. So now let's talk about a specific case. So let's imagine everything but my red is missing. So a scenario which is that we are going to be using we expect to use a birds endpoint. So now we've discussed this with the backend team. We've agreed on what the API is going to look like, what kind of JSON is going to get sent to us. We've documented it. Hopefully, we've reached agreement about whether the best way of handling errors is to send us back a 500 or a PHP error message inside HTML, right? So we've got agreement on all of this. So and now we also agreed how the problems are going to be handled. And so now just small thing, we're waiting for the actual endpoint. So the way some of the general principles that we recommend here is when you do client-side mocking, our recommendation is that you leave, so you're going to have your birds endpoint, right? So your bird services. So that's going to be a service that your controllers, because obviously none of this should have anything to do with your controllers, right? So your controllers are going to use this service. But that service really shouldn't have to know anything about your mocking anyway. Instead, what we want to do is we want to move our bird service is going to be using an API service, and the API service, however, will know how to handle mocking as well as other things. Now, that's generally our preferred approach. I know some of the people like to do the same things with interceptors. Our approach is to wrap $HTTP in a higher level service that can then do things like authentication and like send attaching tokens. And one of those functionalities we put at that level would be mocking. So then the other thing that you want to do is that you're going to be putting data into your mock data into your application. You want to keep that out of your real service. Again, the idea there is that you want the actual sort of the higher level of your applications really be ignorant of the fact that there is mocking logic going on, and you don't want to mix your mocking together, because once you mix it together with your actual code, it becomes a lot harder to separate. And as we'll see, that you do actually want to be able to toggle back and forth between them. And so finally, HackStack provides some of the common functionality that you will need to do those things. And then you will also, if you find that the functionality we provide is limited, then you will probably want to provide your own additional mocking logic, especially when you're dealing with very complex endpoints. We have, for instance, immediately when we started applying it, we've discovered that, well, one of our projects was using FeedHenry, and FeedHenry has a let's say, interesting approaches to returning data. And so the first step that we needed to do is to actually write a wrapper on top of it that actually can simulate not just talking to an abstract API, but talking to specifically FeedHenry. So you will, and the important thing, again, that logic, you want to keep it separate, because the last thing you want to do in your complex applications to mix a bunch of mocking logic together with all of your actual production code. So let's talk about how we would implement the quote-unquote real service. So the real service in this case is the service that your controllers are going to see. Now in this case, we're going for a really dumb, simplified implementation, where really all we do is that we inject the API service, and then we just make calls on that service and return the results. Oh, whoa, magic. Wow, this is fantastic. Now you've got my slide titles. That's awesome. So now this is a very simple service, and of course some people might wonder, like, why do you even need a service for this? It seems like it doesn't really do all that much, but the truth is, in a complex application, this is going to grow. Your service will have to do all sorts of business-specific post-processing of the data that comes out of your endpoint, so you want to actually do all of this here, but meanwhile you offload the interaction with the actual the fetching of the actual data to your API service, which will, in our case, will both do mocking, but oftentimes you will want it to handle things like authentication. Now, the second thing is we're going to separate the mock data. We want to keep that separate so that it doesn't sort of infect the rest of our application. In this case, it's just a constant that specifies all of the mock data that we're going to be returning instead of the stuff that we're going to be getting from the server. So now, in terms of generating data, there's a bunch of cool tools that you guys probably know. There's things like JSON generator, UUID generator, PlaceKit, and all of those provide sort of great tools for generating potentially fairly complex JSON documents that you could use for mocking, so you don't end up typing those things manually or having to write complicated code just to generate some data. So the next step is we will want to implement a mockable API service. So in this case, and this is where HackStack comes in. So HackStack offers, so we inject HackStack as a service, and it has a method called .mock, which basically just takes a bunch of an array of data, which now notice that we don't want to specify that data here. We pull it out of a mock data constant. And what we get back is a mock endpoint. Now, the second thing we do here is we're actually going to attach this mock endpoint to $window. This is so that we could actually interact with it inside of a console, and I'll show you how this can actually help us see how our application behaves under different scenarios. So then finally, we will want to actually, so the other part of our API, our API service implementation is those actual generic .get and get all methods. Those methods will need to actually know how to switch between mock implementation and real implementation. So they will basically look at some flag, and based on that, either go and actually make an HTTP call or use the mock endpoint object that HackStack provides us with. So finally, in our bird service, oh, this got repeated, but now this time you guys actually see it with the title, so that's pretty cool. Again, the important thing here is that your higher level services really shouldn't know about mocking, because if they do, then your ability to swap it in and out is going to be reduced quite a bit. So a couple of key points here in terms of how you want to go about it. So your mock API should match your eventual real API. Now, obviously, it's not, you don't want to match the real API that you've got right now, which is often in the beginning of the project is nothing. But you want it to have a close match with what you expect at the end of the day. And as those expectations change, you will want to probably adjust it. The second thing is that one of the things that this means is that your mock API has to be asynchronous. And this is something that HackStack does for you out of the box, right? It makes sure that when you make an HTTP call, you will get back something, you will get back promises. And then again, your higher level code really should know about mocking, because otherwise you cannot really later switch. So now this allows you already kind of to move towards the situation where your API is not there, and now your data is coming, you have your services, you can develop your controllers, templates, all of that as if you actually had the backend. But it also gives you something else, which is really important, is that it makes it easy for you to mock problems. Problems that are sometimes very difficult to simulate if you're actually working against a real, properly behaving backend. So one of those is slow connections, right? So one thing that we've been finding is that oftentimes, if you're working against if you're working in a development environment, your server is running locally, maybe even, it's responding really fast, it doesn't have much data. So you've gone ahead and you've built a whole bunch of optimistic assumptions into your UI. Maybe you've even gone as far as to really not be using promises, but just kind of assuming that by the time the user gets to a particular controller, the data is already available. Now, you didn't actually make this assumption explicitly, you just wrote your controller that way, right? And this is the kind of thing that's only going to explode in your face when you start dealing with a slower server, right? When you start dealing with because you're assuming, for instance, there's a loading splash screen, and then the user gets forwarded to the next route, and when they get to that route, that controller just assumes that the data is there. But the moment, this really is based on the assumption that the server will respond within that short window, right? So now, when you slow down your server, suddenly all of those problems become extremely visible. So that's one of the things, is because of that, you really want to be mocking slow connections, slower than your server perhaps. I mean, in fact, one of the things that I often advise people, mock it with really slow connections. Imagine that every server request takes 5 seconds to respond. See how your UI is actually holding up then. So the second thing is server-side errors. Again, you want to make sure that you apply. So sometimes it's difficult to simulate a error 500 on a server if the server is actually behaving properly. But one day, that error 500 is going to crop up. And so when you're trying to develop, you want to be able to simulate it easily. So this is something we can do here. And both of those are supported currently. Drop connection, something we don't really quite do yet, but this is also an option. Lack of authentication would be another great one. And then finally, also, really easy way of modifying values and testing things like values being too short or too long without having to go ahead and actually load data into a database, which can get really, really painful potentially. So, etc. So demo time. Let me show you quickly how this works in practice. It's not, oh. That is, what do I do? To display this?
It looks like you're in extended mode. Do you want this on there?
Yes.
Okay.
Okay. So in this case, we have an application. So we've got, now we build this application so that you actually can switch between different modes on the fly. So in this case, we've got a real backend. The real backend gives us those data that's a little broken. Some of the images are actually missing, and a lot of the fields are missing that we expect. So how do we go continuing developing this application with the expectation that all of the birds' data is coming back? So we switch to the to this endpoint. This is the mock endpoint, which really just goes ahead and returns data that comes from this file. One of the things we can try immediately is we can go ahead and type in a lot more data and see how that behaves. We can see, OK, this is what happens. I think we're losing maybe connection here. That's why. No, so one thing that you might notice is that it's a little slow to load. The reason it's slow is not because of the slow server, because there is no server. The reason it's slow to load is because we actually have an artificial delay that is actually randomized so that you won't have any illusions about how fast your application is going to be when it interacts with data. And then the second thing that you could do here now is that what if we want to see actual specific errors? So in this case, as I showed before, we went ahead and we actually put the mock endpoint on our dollar window, so we can now go ahead and access it here. We can do mock birds dot force error. We can do something really simple. Let's force a 500. And then what this will make sure is that now any subsequent requests will give us 500. So I will click on this to reload. And we'll wait for a while, and now we got an error. So now you can know how are we handling this error in our application. In this case, obviously, we did catch it. We didn't do anything particularly fancy about it, and then we can go ahead and actually turn it. I mean, it will continue like this until we turn it off, if we can go ahead and turn it off, in which case we can now go ahead and load again. So there's a bunch of other things that you could control this way, so you can actually see how your application behaves with in different situations. Now, what about when your API does arrive? Because, I mean, eventually, one day, hopefully, your API really will arrive, right? Well, there are a couple of things still you need to worry about, right? So one is testing. We recommend really that front-end developers all need to have good skills in testing back-end API, because oftentimes that's who it falls to. We recommend Postman. We also recommend actually getting familiar with Supertest as a way of doing automated tests against the API that you are being provided. You need to figure out how to deal with changes, right? On that front, we recommend getting to see if you can actually get to run the API server locally, because that really ends up giving you a lot of control over when you can have access to it. You don't have the situations where you really cannot work for a day because you really want to test against real API and it just happens to be down today. And then finally, you do want to actually be able to have an easy way of toggling between client-side mocking and real API. Now, the reason you want to do this is because you go through the phase in the process where the API is sort of ready. It's sort of ready where maybe, like it's working. So, I mean, the API team tells you, OK, it's working now. You go ahead, and it takes you about 10 minutes to find out that it's not working. So you want to actually be able to spend those 10 minutes running your application against the real API, however long it takes, but to be able to switch then to your mocking to actually get your day's work completed. And then finally, it can be incomplete, right? So I mean, it works, maybe if it's even stable, it just doesn't do everything that it's supposed to do. So what you then want to do is you want to be able to extend it. So in this case, we have a mode where it's the hybrid mode, where essentially you are wrapping the results that come out of it. And again, you will be able to later switch. So in this demo that I just showed, this is actually the third option, so this is our live data. Some of it is missing pictures. None of it has scientific name. We have the mock data where the data is entirely fake. And then finally, we have the wrap mode where what we do is we've actually filled in images for the ones that are missing, and we've gone ahead and we've actually put scientific name for everything that's missing. And so now this allows us to slowly transition to using the real API. So we do this by filtering the data through a mock layer. And now, one more thing, this is outside of the HackStack.js specifically, but we do find that there's some small number of cases where you really actually do want to do something on the server side. I mean, the most common one is actually if you want to proxy things for the purpose of adding course headers. Now, if you do this, well, that was a little odd otherwise. So anyways, I'll get to that point in a second. But in terms of the way we implement mocking, so it's, again, we specify the object that actually fills in the value, and then we create a wrapped birds, which works just like the mock endpoint, but it happens to now actually make a real API call. So in this case, this is the values that we're going to be filling in, and then now we're also working on adding an alternative option where you provide a function that will essentially map over the provided results instead. So again, here's where, if you want to get HackStack, you can get it with Bower install Angular HackStack. We called our package Angular HackStack because we expect to make a generic version that you also can use outside Angular. And also you could find it on GitHub. And then finally, the slides are available at that URL. Oh, this came slightly out of order. Oops. Thank you very much. We're asked not to do Q&A during this session, but you guys can ask if you have any questions and get in touch with us through Twitter. Here's my personal Twitter, and then Wrangel.io's Twitter. And also we are outside, so come and talk to us. Thank you very much.
All right.